So guys, this is our mic and this is the USB to TTL device. Blue LED is on. This means PIC is sending something to the terminal. Let's see what we are getting on the terminal. So let me zoom in. You can see that we are getting no whistle because right now no whistle is blown. So let me blow a whistle and see what happens. See, the whistle is detected. It says whistle detected. Now again no whistle. I again blow a whistle. See, again the whistle is detected, simple as that. So let me go to the programming and show you what is happening here. So guys, you can see that we just initialize the pin which will receive the data from the sensor. We have the USB to TTL port, UART port initialized, and then we check if the whistle is blown, and if the whistle is being blown for more than 60 milliseconds, like we are talking the sound is low, but if the same pitch is maintained for more than 60 milliseconds, only then it is considered a whistle. And then we display the whistle detected, and then no whistle if no whistle is detected. Simple as that. So this gives us this result over here. Hello guys, welcome to learning microcontrollers. In this video, I will show you how we can detect sound using a PIC16F877A microcontroller, and then we are going to use the computer to see our output. So we will be using USB to TTL device to send the data to the computer. It will be like using a serial monitor in an Arduino. So on the PIC, we will be using a USB to TTL device to make a serial monitor. So we will simply use our whistle. I will whistle, and whenever the whistle is detected on the computer, it will send the data that a whistle has been detected. Else it will say no whistle. Simple as that. So we will be making a sound detection system. So let's get started. So guys, this is our PIC16F877A microcontroller, 140 pins. It's a DIP variant. And this over here is the microphone sensor, easily available in the market. I don't know what they call it. I think they called it KY038. You can just write on the Google that Arduino mic sensor, or it's a mic. It's simply a mic with a module, or you can directly use a mic as well. So simple as that. So we are going to use this to detect our sound. So let's first of all do the connection. Let me show you how to connect it. As you can see, it has 3 pins, and as you can see on its body as well, these 3 pins are labeled as from the right. It's VCC, then ground, and then the output. And output is a digital output. Either it gives 1 or 0. Now guys, let's connect it. You connect the VCC directly to the VCC of the PIC like this, ground to the ground of the PIC. And for the output pin, that is the digital input output, you can use any available digital input output pin. I'm going to use the pin number D1 for this, like this. And that is the pin number 20 of the PIC. In this way, our mic sensor KY038 is connected with the PIC. Now let's connect the USB to TTL device to send the data to the computer in serial form, just like a serial monitor in case of Arduino. So we will be using this CH340 USB to TTL device. You can use any other USB to TTL device as well, like FT232, CP102, or any other, but you have to install the driver of that device, whichever you use. Now guys, this is a CH340. Let's connect it with the PIC. As you can see that it has like 6 pins. Let me relabel them. Top one is a 5 volt, VCC, 3.3 volt, TX, RX, and ground. Now guys, whichever the USB to TTL device you use, 3 pins are common in all of them. That is the TX, RX, and the ground pins. These 3 pins are in all the USB to TTL devices, whichever one you use. For the power, there are sometimes options like some do have 3.3, some do not have 3.3, that's all. Now guys, let's connect it with the PIC. You will connect the ground directly with the ground of the PIC like this. For the RX pin, you will connect it to the TX pin of the PIC, and the TX pin of the PIC is the pin number 25, that is pin number C6. Now for the TX pin of the USB to TTL device, you will connect it to the RX pin of the PIC, and the RX pin of the PIC is the pin number C7, that is pin number 26, like this. Now these 3 pins are enough because we will not be connecting the power pin, because once we connect this device into the computer will auto power up the USB to TTL device, and our rest of our circuit, the mic and the PIC, will be powered up using a picket 3 in my case. But if you don't want to use the picket 3, just burn the code, remove the picket, and use a 5 volt from here. You simply take a wire and connect this 5 volt with the VCC of the PIC. In this way, once it is connected into the computer, the whole circuit will be powered up by the computer 5 volt supply. Simple as that. But in case like me, you are going to use the picket 3.5 to power up the PIC and the mic, then you do not need the power from the CH340. Just common the ground, and this device CH340 FT232 device will be powered up by the computer. Simple as that. Now guys, this is our total connection. We have our mic, we have our USB TTL device connected. Now let me show you the hardware before we move on to the programming. So guys, this over here is the out hardware. This is the sensor module. This is our USB to TTL device. You can see that it's on by default because computer is giving it the power. So that's why only 3 wires are used. Now guys, let's do the calibration of the sensor before we move on to the programming. So I will power up the whole circuit using PIC16F877A to calibrate the sensor. So you can simply power up the sensor from 5-volt source. Okay, now it's powered up. See that both the LEDs are on. Now I use the whistle. Nothing is detected. So we have to calibrate it as per our sound environment. So here you have this potentiometer. You place a screwdriver on it and rotate it. So rotate it in the opposite direction. Rotate. Now see, it has turned off. It means now it is coming to some reading. Now if I don't speak, see, so I rotate further. Now it's in better environment. Now see, even better. Now even more, so I rotate further. Now see, it is not taking the effect of even my speaking, so it's better. Now I whistle, but it's too less. Now I rotate it in the other direction. See, now it's better. Now it will detect my whistle. See this LED. As soon as I whistle, it detects the whistle. See? 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 So that's how you do the calibration. Now we can move on to the programming. So guys, let's do the programming. So this is our, let me zoom in so you guys can see better. This is the micro C for PIC version 7.2.0. You can use the higher version as well. Higher is always better. Click on File, New project. Now click on Next. Write the name of the project. I write sound detection using mic tutorial by learning microcontrollers. Simple as that. Now guys, this over here is a folder and this is the device. Select any device you want. I select PIC16F877A and this is the clock. This is the crystal connected to the pin number 13 and 14 of the PIC. I have a 20 MHz crystal over there, so I will write 20 over here. Click on Next and finish. Now guys, this over here is our starting window. So before you do anything else, first of all press Ctrl S to save your work. So the work is saved. Now guys, we start the programming. First of all, we initialize a pin, that is D1, where our sensor is connected. So I write trace D.F1 equals to 1. Now trace is the direction register, D.F1 is the pin and the port, and 1 means it's an input. So for this type of inputs, we declare the pin as input because we are going to take the input from the sensor. Simple as that. Now initial state, there is no need of the initial state. It's a sensor, it will auto set its initial state. We give some initialization delay, also not needed, but I always suggest you give it in the one-time loop for the smooth running of the programming. Now guys, we got our sensor pin initialized. Now we get the USB to TTL device initialized because USB to TTL device works on the UART protocol. So we have to select that library. Here you have this UART library. Check mark this, expand this. You have this command UART1 init. Double click on it. This window pops up and go to the example here. In the example, you have this command UART1 init 9600. Copy it, paste it here. Now this is the syntax of the command. It will initialize the TX and RX pins of the PIC of the port 1. This PIC16F877A only has one UART port, but other PICs like PIC18F46K22 have more than one. They have two. So there are two options of UART1 and UART2. But in our case, we will only initialize the UART1. And 9600 is the baud rate by default. So we are only going to send whistle detected or whistle not detected. For that, this is enough. A packet of 9600 is enough. Now guys, give some initialization delay, also not required, but still I suggest you give it in the one-time loop. Now guys, we got our sensor initialized, we got our USB to TTL device initialized. Now we can move on to the forever loop for programming. Start right while one forever loop starts here. ends here. Now guys, here first of all we check if the whistle is detected. Now guys, this sensor, whenever it's high, it means the whistle is not detected. Once it goes low, it means the whistle is detected. That is, I had checked it using a DMM. You can also check it. So if I write here port D.F1 double equals to 0, this means the whistle is detected. Now guys, there is a thing here, because you see that as I am speaking, let me show you on the hardware, that as I am speaking it is blinking. See that this LED is blinking. I speak and it blinks. So this will be detected as a whistle. While in case a whistle is a long sound, see, but our normal talking is small. So we give a delay here, that if the sound is still there for more than some time, only then consider it a whistle. In this way we can make it a whistle. So similarly, you will play this with this delay to detect various sounds. Like if it's there, the same pitch is there for a long time, it means it's that sound. If it is there for a long time, it means it's that sound. That's how you play with this. So we do is that we add it again. Now if the sound is detected but sound is still there, like a whistle for more than, I say that I make it like 60 milliseconds. Although it is very less, but we will start with this, we will change this in case needed. Then consider it a whistle, that the whistle is detected. Now we will send a string on the screen using the serial terminal that a whistle has been detected. For that, go to the UART library. Here you have this command UART1TX idle, double click on it and go to the example here. Here you have this command, copy this, go back, paste it like this, give the ending brackets like this, make it look presentable like this. Then guys, inside it we send the string. So go to the right again. Here in the UART library you have this command UART1 write text, double click on it, and here you have this command UART1 write text. Only copy this command, go back, paste it inside the UART1 TX idle bracket. This command will check if the TX buffer is empty. You can go without this, but there is a problem, you will get a distorted data. If you use this command, it will only send the data if the TX buffer is empty. So there will be no distorted data. Now here you write whatever you want to send in the UART1 write text command. So I will send that, okay, something which, okay, I use these signs to make it look beautiful. Percentage signs, okay, percentage signs and some spaces, and in the center I will write whistle detected, and then again the percentage signs to make it look presentable. We have 9600 baud, that's enough, we can send such long text as well. So it will send this and then it will stop. So it will be better for us to read that whistle is detected for like 1500 1.5 seconds, 1500 milliseconds. It will stop for 1500 milliseconds. Then guys, this is it. Now the whistle is detected, and if the whistle is not detected, then else it will send, we will simply display on the screen something called like this. We just display, just change the text inside it, whatever you want to send. I write here no whistle. Okay, simple as that. It will keep on sending this if the whistle is not detected, but if the whistle is detected, only then it will send this, else it will keep on sending this. Okay, so simple as that. Now let's build the code and see what happens. Okay, it's built successfully without any errors. Now we go to the PIC16 programmer tool. Here I go to the file, import hex file. Here we just created this file, double click on it, click on write. Okay, the new file is being written. We wait, and let me zoom out and go to the hardware. This is the hardware. Okay, let us write the new file. Okay, now the code is running. See, it's blue now. It is sending the data. Now let's see what is the data we are getting. So let's get to the USART terminal. Go to your micro C for PIC, go to the tools. Here you have this USART terminal, click on it. Select the COM, whichever is related to your USB to TTL device. My is COM8. Baud rate is 9600 that we set in the programming. Click on connect. Okay, we are receiving data at a very fast rate. It says no whistle. data is coming, but it is at a very fast rate. See that? No whistle detected. And secondly, this is slowing down because I am recording the screen at 60 FPS. So that's why it is not showing at that good speed, because screen recorder cannot cope up with this. But it is showing no whistle right now. Now I blow the whistle. See, whistle detected here. Okay, let me pause this. So you can see that here it is, the whistle detected. See, it has detected our whistle. I connect this again, we clear it. Okay, let's connect. Okay, no whistle. It is showing no whistle by default. It is slowing, it looks like it's slowed down because I am using a screen recorder and it don't have very fast speed to cope up. So now I will blow up the whistle. See, the whistle is detected. See, when I am normally talking, it is blinking, but it is not detecting the whistle, and this is all because of a small delay that we gave there. Now I show you both the LED and the screen as well. See, I am talking to you, this is blinking, but it don't says that the whistle is detected. Why? Because we have added a small delay in the programming. That delay is playing its part now. That's simple thing. Now I again blow up the whistle. Sorry, it was not a good whistle from me. I again blow up. See, the whistle is detected. Now this was a good whistle. See, again after displaying the whistle detected for half a second, it will continue. This is showing this data continuously. This is because of the screen recorder, you cannot see it being shown continuously. Now again I will blow up the whistle. See, no whistle detected. See, the whistle is detected. Simple as that. I'm not very good at whistling. I hope you are. So see, this is it, guys. This is simple as that. You can play with the code and you can make various codes to detect various types of sounds. So that will be of great use for everyone. So guys, if you have any questions, you can ask in the comments. I hope you learned something from this video. Thank you very much for your time, and we'll see you in the next video.